Hello, everyone. Hello, hello. Thank you for coming out. This is the DBA Fundamentals Virtual Chapter, and we are here today with our speaker, Kevin Kline, and he's going to be speaking about architectural choices that affect performance. I'm really looking forward to this presentation. A little bit of housekeeping, and then I'll turn it over. The organizers here, there's actually 3 of us here today. Steve Cantrell, and there's his Twitter handle, Shane O'Neill. Warwick Rudd actually handles the Down Under sessions that we have once a month. Kevin Wilkie, and then myself, and then our contact information as far as Twitter is right there. You can reach us online. Our website, dbafund.org, where you can see a list of all of the sessions. If you get our email subscription, I do it on Mondays, then it actually lists everything too, but it only lists the next few months. That will list all of them for you. We also have a YouTube channel, dbafundtube.org. It actually has like 4 years worth of content. So there's a lot out there. It's amazing. And this will also be out there within a couple of days after the session. You can find us on Twitter at dbafun. We tweet about the sessions coming up as well as some other giveaways and stuff. And I'll give you a little heads up. I'll say it again in just a moment, but be watching for it in March. That's for sure. We also have a channel in Slack, so you can go to the SQL community, and we have a DBA Fundamentals chapter channel. We can answer questions as well as actually give information about these sessions and speakers and such. And then also we are ramping up our LinkedIn group. It's been around for a while, but we haven't really been advertising it too much, but we are making sure that we get everybody joined up and really give some good content and such out there for that as well. Kevin Kline is with Sentry One, and this is our primary speaker, sponsor. Sentry One actually helps you build, test, document, and monitor SQL Server, both on-premise and Azure, and the Microsoft data platform. You can reach them in the community, Facebook, Twitter, LinkedIn, normal kind of ways. There's also a lot of stuff you can look at online, so make sure to check them out. You can go to their websites at sqlperformance.com. You can look at a lot of blog entries and such at blogs.sentry1.com. They also have a lot of educational and product videos that you can reach at sqlsentry.tv. And then the last bit I find very, very helpful for myself, free query tuning advice. If you just go to answers.sqlperformance.com, it's awesome. You can also download trials of their software at sentry1.com/trial. And they have a free Plan Explorer, sentry1.com/plan-explorer. And what's amazing about that is actually a plugin for Management Studio. So rather than having to open up another app and all that kind of, whatever, you can just right-click right within SSMS and open it up, and it really gives a lot of information. I use it myself, and I know a lot of people who use it. So go out there and try it out. Our chapter news, we are going to be giving up giveaways from January through June. January and February, we'll give a $100 gift card for anyone, for not anyone who attends, but it will be pulling from the session of everyone who attends. So we will be picking and reaching out to the winners. Since you're here, you guys automatically get a, not a ticket, but a chance at that already. So woohoo! In March, the giveaways will include attendance, but also, just as a side bit, watch Twitter and watch our email subscription list. We'll be putting out additional giveaways through those, so watch out. Woo-hoo. Also, we'll be giving out the discount code for Pass Summit very, very soon. As soon as we get it, I think we'll be passing it on to you guys. We are a member of PASS, and there are a lot of virtual groups out there. This just kind of gives you a heads up as to which ones are out there. Multiple languages as well as multiple topics. So if you have a specific need or what have you, or want to learn about something more specific than just overall database fundamentals, there are other virtual groups, and you can belong to as many as you want. Here are some upcoming virtual chapter sessions. So Hebrew and Italian, there's a DevOps coming up and a PowerShell as well. Our DBA administration virtual group, and then we're back here again on March 5th. And then there's another professional development as well. There's a whole more list of things than just this. These are just the most recent for you. More awesome training or learning and such are SQL Saturdays. They are free events that is a whole day dedicated to learning and networking and all of that. I still remember mine, and I have great friendships that I've made and on all that, memories. So it's been great. You can go to SQLSaturday.com and look at all of this, all of them. These are the most upcoming ones, and they are a global event at this point. So both United States and Canada, as well as Latin America and other countries as well. So check them out. Lastly, we are recording this, and you will be able to see this within a couple of days at dbafuntube.org. All right, with that, let's turn it over to Kevin, our speaker.
Great, thanks very much. So let's just take a moment and confirm that you can see my screen coming through there. Is it something you can see okay? Hello?
Hello, Kevin.
Yes.
I am sorry. I thought somebody else was going to be here. I just was going to join. I'm in the hospital right now with my dad, but I can get it started. Looks like nobody's starting.
No, it looks.
So, oh, Kevin's there. Kevin's there.
Let me make sure that things are going okay here. Take a look at the audience view. All right. And I thought one of the other, okay. So Greg tells me you can see the slide. So I'm going to go ahead and go forward with that. Thank you, Steve. I appreciate that input. And I apologize. Sorry?
I'm sorry. You were already started.
Oh, yeah, no worries. Folks, I apologize that I am coming to you from a hotel in the Frankfurt, Germany area. And I'm not sure if you are familiar with the broadband situation here, but it's not very good. So if things don't come through well, apologizing for that in advance. I don't know what to say, but I'm getting a call and they will. Hold on a moment. Kevin Kline here. Wow, we've had a weird morning, or a weird kickoff here. So I apologize again for the interruptions and the hiccups along the way. As mentioned, I work for Sentry One, and we provide a lot of neat tools for the SQL Server market, and I appreciate you giving me a few minutes to speak with you today. We are known in the business as making some of the very best tools of all the different kinds of things you might want to buy for SQL Server. However, the thing I really like to point out as being kind of our claim to fame is not just the products, but it's the two elements here on the bottom of the screen. First of all, our amazing expertise. So we have 7 MVPs on staff, Microsoft Most Valuable Professionals. And we make products by SQL DBAs, for BI people, for developers. And we treat you the way we wanted to be treated when we did our work as enterprise DBAs. So when you look at aspects of how customers interact with their vendor, we beat everyone in the market. We are not only in the top 1% of other SQL Server tools vendors, we're in the top 1% of the entire tools and software industry in terms of customer satisfaction and things like that. Now, one thing that I also want to point out is there's something here called Trust Radius. And Trust Radius is really cool. It is to enterprise software a lot like, I guess you could say, Amazon reviews are to, to like buying a screwdriver. I always read those reviews because I want to make sure it fits in my hand and that sort of stuff and didn't fall apart too early. And that's what you get with Trust Radius, but you get that for all kinds of enterprise software. Like if you wanted to buy an inventory management system, or maybe you worked at a doctor's office and you wanted to buy a scheduling reservation system. And the average score is in the middle 6s to low 7s. In our industry, monitoring and SQL Server tools, the best score aside from us is 7.2. And our score as of today is actually 9.1. Again, we're in the top 1% of all vendors in this space. We really take care of you and do everything we can to make sure you have a white glove, wonderful experience with your products. So that's Sentry One. They're the ones who enabled me to come on today and share with us. A bunch of our products, as mentioned, Plan Explorer makes query tuning what it should be. And so that's the kind of thing that if you write SQL statements or procedures or functions or any of those kind of things inside a SQL Server, this is a product you want. It has it has millions of users, and we don't even ask for an email address. So that's one of our most famous products. I would say our next most famous product is SQL Sentry, which monitors your SQL servers and gives you all kinds of performance advice on them. And then I'm going to go ahead and skip this page because Glenda had already mentioned it. One thing I do want to mention, though, is that we have concentrated several of our other web pages, our websites in the past, into sentryone.com/resources. So if you'd like to see probably almost 24 other videos of mine, as well as videos from other members of our staff, go to sentryone.com/resources. And that's where we also have white papers. We have a series of ebooks that are $10 each in the Amazon Kindle bookstore. You can get them for free there. And they're not little throwaway pamphlets. The smallest one is 320 some odd pages in length. So these are real books. And they're written by real luminaries in the business like Paul Randall and Glenn Berry and Aaron Bertrand. So take advantage of those. My name is Kevin Kline. I've been in this business since before SQL Server was a Windows product. And before that, I was, 6 or 7 years working with Oracle products. And many of you might know me as one of the original founders of PASS, of which you are a member since you're attending this virtual chapter of PASS. I was also president of PASS for 2 terms in the aughts from 2004 to 2008. And I'm the author of many books like SQL in a Nutshell and that sort of thing. So you might have seen some of my content elsewhere. We have got a ton of stuff to talk about, though, and I'm not even sure if we're going to get through all of it in the amount of time we have today. That's why I've asked to hold our questions until the end of the session so that we can get through, knock it out of the park, run through some demos, and just get some good information into your hands that you can use and maybe experiment with and play with after the fact. So if you have a question as we go along, I encourage you to go ahead and put those into the Q&A feature. And I will, if I don't get to answer them all today, then I'll write a blog post afterwards and make sure that we get all of these answered for you in one way or another. So hopefully that sounds fair. So let's dive in and see our first topic here. So the first thing I want to talk about is just make sure everybody is aware of the way that indexes and tables work in SQL Server. To make a long story short, tables come in 3 forms. Basically, SQL Server stores data as either a table without a clustered index, that's called a heap, a table with a clustered index, and then you can also create another object called a non-clustered index. And a non-clustered index is actually written into the same structure as the others. They all use an 8K data page. And that's written on disk as an 8K data page. And it's written up into memory in that way too. So when SQL Server is building out the, filling up the data cache, which is full of tables and indexes, when it's filling up the plan cache, those things are stored in 8K pages. And so there's a little header in each of these 8K data pages. That's why you don't get the full 8192 bytes. You only get you get the significant portion of it, but you lose a few bytes because you have the page header, and then you have a slot array at the tail end of each of these data pages to keep logical track of the orders within that page. So if I have a page and it's got a bunch of records in it, Cooper and Hofstadter and Kuthrapali and Walowitz and all these different names, SQL Server keeps them in order using that slot array, because notice the quick key is actually record number 4, right? Not record number 5. So it's the slot array that keeps track of how you write when you're writing in new records. Now, it's important to know the difference between heaps and clusters, because clustered indexes, because heaps do have situations in which they offer better performance. With a heap, we have no clustered index, which means there is no sort order per se on the table. And the lowest level of pages written are what we would call the leaf level, because when you invert a B-tree index, a balance tree index, it looks kind of like an upside down tree. So we call these the leaf pages. And every so often, about every 4 gigabytes in that file, there's going to be an index allocation map. There's going to be a GAM, a global allocation map, an SGAM. Those appear every so often. Every 64 megabytes, there's something called a PFS page, which is a page free space marker in that heap. Now, you compare that to a clustered index, and what we have is called a balance tree. Now, it's commonly called a B tree, and a lot of people say that's a binary tree, but that's actually inaccurate. It's a B tree. And what SQL Server does is it sorts all of the records down on the leaf level, all these leaf pages, so that they occur in an assorted order. And then you're able to find your way quickly from the root to the specific page you need by not having to read every single page in the leaf pages. And that will save an enormous amount of time. Now, if you're wondering, where is a heap more valuable than a clustered index table? Well, heaps are better when you have massive amounts of ETL happening. And so it could be a lot faster if you're just doing, let's say, a 2 million record load into a table. And then you're going to move that data to, say, another intermediate table or something like that. So heaps can be faster there. And the reason for that is they don't have this little object in the lower left corner. Or they don't have a, typically you won't have any non-clustered indexes in that scenario when you're doing that big ETL operation. Now, heaps can have non-clustered indexes. But what a non-clustered index is that is a separate set of structures. So let's say this particular table on the right-hand side is employees, and the clustered index is on the employee ID. But then we also sort by all kinds of other things, and we filter by all kinds of other things in the employee table, like we filter on the hire date, we filter on first name and last name, we filter on the department, all kinds of stuff like that. So for each of those, we would very, very likely want to create a non-clustered index, which creates, again, index rows. And if you were to look at them with a hex editor, they're rows of data, just like a table has rows of data, except these contain pointers to specific clustered index keys at the leaf pages. So that way, if you were sorting or doing a where clause on the, let's say the person's job category, it would be able to find all of the people that fit a particular job category very quickly and then link back to the clustered index to show you all of those records. Now also notice I've got this little double arrow here in each of these locations for the non-clustered and for the clustered index. That's for something called a doubly linked list. That way SQL Server could start a scan on data page 150,000 and continue that data scan to 172,000 without having to do a full table scan. You don't have that in a heap, so you have to do a full table scan anytime you want to isolate a specific group of records. So that's a big difference there. You want to go through in your database and make sure any significant table that is going to see a lot of usage has a clustered index. So, and there, as I mentioned, is a connection between those non-clustered indexes and the clustered index, okay? Now, as I mentioned, you can have non-clustered indexes on heaps, but they have to create a different kind of pointer called a forwarded record pointer to the specific pages in the heap itself. So that means you can get better performance when you're using the non-clustered index than nothing, but it is still not as good as what you would get with a clustered index. Okay? All right. So here's another big architectural issue that really seriously impacts performance. And I'm going to touch on the bit about indexing as well. One of the things I see happen really often is with developers who are using an ORM. For example, they're using an older version of Entity Framework, or maybe they're using InHibernate, any version of InHibernate. It will create the clustered key by default on a GUID. And GUIDs are terrible for clustered indexes. They're horrible. The main reason for that is that GUIDs are non-sequential. They are globally unique identifiers. That means you can't really put them into a realistic sorted sequence. That means they cause enormous amounts of hotspots, which means blocks on the page at which it's doing inserts. It causes on this middle column here, it causes an enormous number of really bad page splits and immediate and heavy table fragmentation. GUIDs are terrible for the clustered index key. Now, what causes people kind of a problem is they don't realize that the primary key can be something besides the clustered key. So you could create a primary key on a GUID, and I'd have no problem with that. And this is what a GUID looks like. You know, it's a big, long hexadecimal number. There is something called a sequential GUID, and it has less problems with causing bad page splits, which are a really serious I/O throttle on your performance. But they do have all the other problems of being really wide, and they cause compression problems, they cause hotspots, and as I mentioned here, they're hard to troubleshoot. Now, what I mean by that is, if you take a look at this number here for the order ID under the GUID, you can't remember that, and it'd take you half a minute to write it down. But if you had an order ID that was a real number, say 1,553,000, well, you can kind of hold that in your brain, and you can understand what that number means. And so that's a lot easier to deal with if you're trying to troubleshoot some data problems. Okay? So the other thing that is super important, and it goes back to the previous page about indexes, is this one word, wide. So let me go back to the previous slide. What does that mean? Why is that a problem? Well, what it means is that whatever you create your clustered index on, it fills up these intermediate data pages. And that takes a lot of room if it's really wide. For that matter, every non-clustered index points to the entirety of the clustered index. So maybe you've used a clustered index that has multi-part columns. Like whenever I go to my doctor's office, they ask for my first and last name and my date of birth. I'm not really sure why, but that's 3 columns. If that was a clustered key, that means it would have every row of every non-clustered index would need to store last name, first name, date of birth. That's quite a lot of data. So I've seen situations in which we've changed from GUIDs to, say, an identity column on a big int. And the amount of data consumed everywhere in the database dropped a couple gigabytes because we went from a very large GUID data type to a much, much smaller int or big int data type. And it just took up less space. And since it appeared in every record of the clustered index and in every record of the non-clustered indexes throughout, the amount of savings was enormous. All right. Now, much of what I'm going to talk about in the next couple of minutes is predicated on full pages. Well, what does that mean? Well, as I mentioned earlier, SQL Server uses 8K data pages to get all of its work done. Now, on the disk, that is, let's say that's a great deal slower, your hard disk. So imagine an analogy I'm going to use for full pages and empty pages and how it makes things take so much longer if you don't make sure every page is full. So let's say we've got it's an old-timey plantation or maybe a French chateau or something like that. You've got a beautiful well that you draw water from, and you want to take a bath. So you take that water in your wooden bucket and you fill up a 4 or 5 gallon copper cauldron that sits in the fireplace and warms up the water, right? And when you take that 4 or 5 gallon, that'd be 20 or more pounds of water, by the way. A gallon of water weighs 8 pounds. So you take that very heavy cauldron and you pour that into the bathtub you're going to take a bath in, all right? So you can imagine it's going to take several trips back and forth to the well, to the fireplace, then to the bathtub. Now, if our data page, if you will, or our index page, in the analogy, it's a bucket, okay? That's what moves everything around. That's what stores the water as it goes from one place to the other. If we only fill this bucket up halfway, it takes twice as long for us to get that bathtub full, right? If we only fill it up a third of the way, then it takes 3 times as long. So every time we make the trip back and forth to speed things up, we want to get this bucket as full as we can. If we don't, it will take much, much longer. And it is the same way inside of SQL Server, especially for write operations. Now, there are some differences especially for read operations. I got the cart before the horse. There are some situations where write operations don't favor that, okay? And I'll explain that in a moment. But if we are going to read pages from the database, we want those pages to be as fast into memory as they can be. We want them to come as fast off of the database as we can, right? So that's the kind of thing that we're trying to do here. So a couple things to keep in mind. Each row size is limited to no bigger than 8096. I'm sorry, your row size can be larger, but each page can only hold 8096 of data. And so one of the things that this means is avoid the max data type if you can. Sometimes people just use max as kind of a shortcut, and they put in, a table name or a column as varchar max. But really, if you were to check the length of the data in that column, you find that nothing in there is greater than 5,000 characters or something like that. Well, then in that case, make it 5,000 because you're leaving tons of empty space on that page, even though you've defined it as max, right? So it's having to go back and forth more times because of it. Another thing we see frequently, particularly with those who are not well versed in relational databases, is they might put in too many columns, either on the primary key, the clustered key, or just too many columns in general. And so they haven't actually put the table into second or third normal form like they should be. We see lots of situations where the data is malformed. We see lots of situations where they use a particular column as if it is, a subtable, if you will. And so we treat it as a CSV or XML or JSON, when in fact we have XML and JSON data types in the later versions of SQL Server. So it's the kind of thing that if we're going back and forth more often than we need to, we slow things down. Now, this is on the design side of the database. Now, flip this over to the development side of the database. And what happens if you write a query that only needs 3 columns from a table that has 14 columns in it, but you say select star from that table every time you reference it? Well, again, you're getting way more data than you need, and so you're facilitating multiple round trips to the database when you don't have to, because you keep filling up that 896 row count, and it spills over to another page and another. Whereas if you were only using the 3 columns that you needed specifically in that query, you could fit a heck of a lot more records onto that 8096 size in of the data page and get a lot more data into a fewer number of pages. And so the trips back and forth are greatly reduced. Okay? All right. So what about with write performance? I mentioned that is a bit of an issue. So what happens here is with write, there is a situation in which we have that root page, we have all the intermediate pages of the clustered index, we have the leaf pages at the bottom. However, with every page full, that's really, really good for those reads so that we get less, we get more data into those data pages and we make less round trips. But what happens if we insert or update the values in one of these completely full pages? Well, that causes something in SQL Server known as a page split. And I mentioned that GUIDs cause double quotes bad page splits. Well, this is that bad page split I was talking about. What happens is SQL Server, with that DML operation, that insert or update or merge or what have you, it says, oh, the clustered index tells me I need to insert into this page, but the page is full. So what I have to do is I take data equal to about the bottom half of this page, and I put it into a new page. And I put the new record that I just wrote into that new page as well. The only problem is I put that in the first available spot I can find in the data structure. So if maybe a delete happened yesterday and there's 500 pages free in one part of the database, and we're doing an 800-page insert, then it would put 500 pages into some random place in the database and then the remaining 300 pages at the end of the database where it's actually open. And so this is the kind of thing that, especially if you have hard disk-based IOPS, you're going to have a really, really hard time getting good speed. It doesn't really hurt too much on SSDs if you are using SSDs, but it will hurt a lot on hard disks. And this is basically logical fragmentation of your tables. That's why you'll see very often DBAs will do preventative maintenance routines, say every weekend, to rebuild the indexes on their different databases. Now, if it's a read-heavy table, they'll probably rebuild these indexes at 100% full. Meaning, yeah, I'll get some more page splits, but since this is used primarily for read operations and reports, that's good. On the other hand, if this particular database, and this particular table, I should say, has tons of inserts and updates and deletes happening to it, you probably want to leave each page a little bit empty by itself as you go along and take care of the grooming and maintenance of the database. So in that case, what you want to do is when you rebuild the index, you want to use a fill factor setting. That means when you rebuild the index, and let's say you set the fill factor to 80, then only rebuild these data pages 80% full and leave 20% full afterwards, so that if we insert a random record into one of these existing pages, it won't cause those page splits. And that's a great way to reduce that really terrible page split situation. Sometimes in really hard press systems, those page splits even happen up here on the index pages. And so in those situations, you also would want to use this pad index option as well in the syntax of the statement. All right. Now, I had mentioned also that there's a problem with concatenated indexes. Okay? Concatenated indexes can be a real problem if you when you're writing queries against a concatenated index. SQL Server actually analyzes the indexes going from left to right. Okay? So if you said where last name equals Austin, it would use the index. However, if you didn't have a separate clustered index or non-clustered index on any of the other columns, if you said where last name is like Austin and first name is like K.A. and street is like 1010, it would definitely use that index. But again, if you said where street is like 1010% sign, it would not be able to use this index. Okay? So that's one of the kind of things that you need to be aware of. Not only that problem I mentioned earlier, where every value in the clustered key is stored in all your non-clustered indexes, but you do have some querying issues. So where last name equals A, F name equals B, street equals C, that'll work great. Where A and B have a value, that works great. But the index will not work if we start on the B column or the C column, okay? Or another one. So it's one of those things that is something you need to be watchful of. Now, if you're running on older versions of SQL Server, and by that I mean all the way up to SQL Server 2008 R2, which of course is going out of service in the very near future, there's an aspect of coding that can actually give you a performance boost. And you probably remember from algebra, you had the associative property, and that said if A equals B, then B equals A. And then there was, the commutative property that said, in parentheses, A equals A plus B equals C. Then commutatively, that would mean that no parentheses A would equal B plus C in parentheses. But the transitive property was if A equals B and B equals C, therefore A equals C. And so in those older versions of SQL Server, if you would actually add that extra string into your where clause or into your join statement, you'll get better performance. This is greatly reduced in the newest version. It can help in the newer versions of SQL Server. It certainly won't hurt, but usually you need to have a million or more records in that given table for it to make a big difference in performance. All right, data types. Okay, this is a big issue when it comes to architecture. People are like, oh, yeah, maybe I'm going to waste some space. That's it, right? Nope, it's a lot more than that. You have a lot of issues you've got to deal with. Things like illogical data type choices. These can be significant problems in coding. I've seen a lot of technical debt accumulate around using poorly chosen data types, illogical data types, using that max data type where it shouldn't be used. Using things like date time 2 when date or small date time would suffice. This is a really interesting one. If you use in varchar or in char and you don't need it, you're not taking advantage of Unicode, that's a big performance impediment. Or if you have columns that are marked as not null, when they shouldn't be, or vice versa. You've got them marked as nullable, not null, when they should be null only, or rather, no, they should have a default value and an inputted value. And then let me actually go ahead and show you a couple demos of that, and it's around this idea of implicit conversions. So what do we got here? What happens is there are certain data types that seem like they are completely compatible, such as in varchar versus varchar, right? So if I have a stored procedure that references a column, in my stored procedure, my parameter is marked as in varchar, but in my table it's varchar, that's okay, right? Well, SQL Server actually will take care of that problem for you. The problem is it will make your CPU blow up. The reason for that is in varchar and varchar are completely incompatible data types. One is Unicode, which is 4 bits per digit in the string. The other is standard encoding, 2 bits per digit in the string. Completely different encoding methods. And so SQL Server takes a look at this and says, oh, you know what? I think you probably want me to put a implicit convert function on that so that it'll work right. And that's what it does. And you can see here in this example written by Jonathan Kahais, it can spike your CPU in a big way. Your batch requests per second drop because it can't sustain all that work. The amount of time to finish the batch went up by 10 times. And there are lots of data types that this happens to. Numeric data types, which have decimal places, that would be money, that would be float, that would be the decimal data types, and integer data types. They are not directly convertible. They have to be implicitly or explicitly converted. Same thing with integers and characters. And the other really, really sneaky problem about implicit conversions is that whenever you put a function call, like isNull here in the example, on an indexed column, SQL Server can't use the index. So you lose that capability. So let's take a look at the example I've got here. And let me show you a little bit about that. Okay. So here I've got a couple references to some tables. Okay. Business entity ID, national ID number, login ID from the employee table in AdventureWorks. Let me turn on the execution plan so you can see what happens here. Here, when I run this particular statement, of course, it comes right back with a results set. When we look at the execution plan, you can see there's a warning, and it says right there, this happens, I think, if you've got the latest version, couple versions of SQL Server Management Studio, it will show you this. We've got an implicit conversion right here because it's having to convert one of the data types to to an equivalent data type, excuse me. Also, it cannot do a direct lookup. What we would expect to see here is an index seek on the employee national ID number, but it can't use that index. It has to do this big, slow scan of the index. Now, let's put it in quotes and see what it does. And again, came back with the results, right? SQL Server is designed to give you an answer, even if it's not the best way, best formation of the syntax. Here we have an index seek. And notice the warning has gone away. We do not have a implicit convert happening. And then finally, let's put that little N on the front to tell it's an in varchar and see what happens. And it's able to handle that one. Now, let's take it a little bit further. This can happen not just with regular old queries, but let's say with stored procedures, for example. So here I've got category ID in the product category table. It's an integer. And then I've got the product table, and I've got category ID, and it is a varchar 10. All right. So let me go ahead and create these tables. And I'm going to put some data into them just to get through that. Okay. Now let's take a look here. And I'm going to define category as an integer. I'm going to give it the value of 2. And in one of them, I'm going to cast it as an integer, and in the other one, I'm not going to cast it as an integer. I'll leave it at default. Now, when we look at the execution plan here, we see that the first version has that warning. I haven't cast it as an integer. So one of those two mistakes it for a convert implicit operation, and we see that the clustered index must be scanned rather than it getting to do a seek on it. If we look at the second version, it also has a implicit conversion. That's because I put it on the wrong side in the join down here, right? And so you can kind of mitigate the problem if you explicitly cast it to the proper data type. But if you don't, SQL Server will cause this to happen in the background, and that will impact your performance both from the CPU standpoint and from all of the IOPS. Now, one of the things that is pretty neat as well that I want to show you is that there are a couple ways you can actually just take a look at your execution plan cache, and we can check to see what we have in terms of different queries sitting in the cache. And let me scroll down here. I'll look for one that's not in master. Oh, I didn't find it. And that's because I'm in master. Let's go to AdventureWorks over here. And so we should see all of our different statements that are in the cache in the AdventureWorks database that have an implicit conversion happening. And you can see there's a lot of other stuff that shows an implicit convert, but we'll find the one that I just ran down here at the, let's see here, in the list. There it is, right here. Sorry about that. There's another one written by my buddy Jonathan Cahias, and this one's a little bit more detailed, a little bit more accurate. You can run this in production. It is safe to do that, but it is going to, scan all of your plan cache, and so it could slow things down. You got to be careful about that. So here it is. It found it right away, and a couple others. There's also a little helper script you might want to use as well. This is written by a consultant out of London named Ian Sturr. And what Ian has done here is he's written some code that will look at your entire database and tell you if you have a column name and if it is different from other column names in terms of its data types. I don't think any of my databases have too many that are like this, that are a problem. But sometimes, so here we have a column called padding, and it's a char 6,000 in one case and a char 4,000 in another. So, in a situation like that, I would want to know that and make sure they're all the same size. That way I can remediate as needed as I, write code and so forth. It's kind of fun to actually run this particular script on Microsoft provided databases. Try it on a SharePoint database at some time, and you'll be shocked how many rules of good design that they are breaking throughout. So it can be kind of scary there as you deal with that. Okay, so let's go forward. Again, I'm not sure that we'll get through all of the slides that I've gotten here, but you'll be able to get access to those afterwards and enjoy that as well after the fact. So what do we have here? Microsoft has provided a really useful data type conversion, spreadsheet graph, if you will. You can download it at that first link there. And so this tells you right at a glance, for example, in varchar, what it is compatible with and what it is not. So for example, it's not, you'd have to explicitly convert it to get it to work with a, what is that, timestamp right here. And conversion isn't even allowed to a unique identifier, it looks like. Or maybe that's image. Yeah, that's an image data type. So this is the kind of thing you want to have. In my case, I just printed it out about the size of a index card and taped it to my monitor for a few months until I got to know it. All right. Now, this is one that surprises a lot of people. they don't realize that adding foreign keys and different constraints actually improves the performance of SQL Server. Now, many of you have probably heard that when you create a foreign key, SQL Server does not automatically create a non-clustered index on that foreign key. So you know to go and look for all the foreign keys in your system that don't have a non-clustered index, and you'll go and create non-clustered indexes on them. However, as I say in some of these other bullet points, having those extra constraints there will actually improve performance. And let me actually flip over and show you an example of that. Let's see here. I'm going to start at the bottom actually and work my way up here. So there's something called foreign key table removal. So here we've got, we're selecting order ID, order date, customer ID, and we're doing it for all the order headers that have matching records in the order detail table. However, that foreign key guarantees that the rows exist in the customer table here. And so no columns are required at all from that customer table. And so we can see that it's able to do just an index scan on one of the two tables right away. So SQL Server generated a better execution plan right off the bat with that situation. Now let's change things up a little bit. Let's take away that foreign key constraint. Okay. Now let's get an estimated plan on that. I'll click that button here, and you can see I have to do clustered scans on both of those tables, even though we're not retrieving any data at all from the customer table. Okay. Whoa. You know, what if those tables have bazillions of records in them? Yep. You will be reading all of those data pages associated with that table. Now I'm going to alter the table and put a check constraint on it, but we didn't actually ensure that the data was checked when we created that constraint. So now that we do the same thing as we did before, SQL still has to do scans because it doesn't trust the data, right? So it scans both tables even though we only need the data from one of the two tables on that join. So now I'm going to use this magic a magic little clause here with check, okay? That says make sure that this works, that the foreign key constraint is maintained. And so when we look again here, I'll get that. Now we see we only do one scan from one of those two tables. So it saved us a ton of work. And there's other things too that happen. For example, when you have clustered, when you have those indexes available, take a look here. So watch this. In our execution plan, it actually turns this subquery, it changes it from a query into a join. That's called simplification. So SQL Server will do that sort of thing wherever it makes sense. Okay. Here's a more elaborate query. And so we'll see the same sort of thing happen here, where it does two hash matches rather than two nested queries. And then the last thing I want to show you is that SQL Server, even if you're just doing, if you have created check constraints, so there's foreign key constraints, there's primary key constraints, there's unique, and there's check constraints. Even check constraints can improve your processing time because of something called contradiction detection. So here we have a built-in contradiction in this query. Unit price is greater than 50 and unit price is less than 25. That's a contradiction. SQL Server knows there's no result set. However, if you have a check constraint on that table and you put in something into the where clause that breaks that check constraint, same thing happens. It will detect it and it won't even have to process it. So it will save you a lot of time. Okay? All right. Now, SQL Server does a lot to try and figure out the optimal plan. That's different than the best plan. Oh, what's the difference between the best plan and an optimal plan? Basically, time. Okay? So what we have here, imagine we've got a table, as I say over here in the third bullet. We have 4 tables, rather, A, B, C, and D. Each of the tables has a clustered index and 3 non-clustered indexes. That means that SQL Server, actually move this out of the way, that means that SQL Server has 72 different physical access methods per each of those tables when it is assessing that in a join. On top of that, SQL Server will do those associative transformations that I was telling you about. So it tries every join order, all 24 of them. And then on top of that, SQL Server then also has a bunch of physical operations it can use. It can use those 72 physical data access methods, 120 possible logical join orders, and then it has the 3 join algorithms of a hash, a merge, or a nested loop. So that means for a 4-table join with approximately 4 indexes each, SQL Server has to figure out a plan that you can get satisfactory performance with out of about 26,000 alternatives. That's where this optimal versus best plan comes in. What SQL Server says is to evaluate all of one set of strategies and all of another set of strategies will take almost undetectable difference in time to complete that. Whereas just figuring out which strategy is most efficient, it takes 10 times as much time to do that. So what SQL Server does is it says, I'm not going to give you a good plan, I'm going to give you a good enough plan. And so that's what it tries to do, is it whips through this stuff super fast and just gives you the best plan it can figure out. And many times that is going to be the very best plan that there is, but it's not always the best plan. Let me show you in demo a few more red flags that you want to be aware of. So this is just a quick query, and you would run this in a given user database. And what you want to look for is to make sure that you have kind of a logical and consistent means of naming all of your different object types. So in this case, I see my foreign keys all begin with FK underscore, the table, and then the column. And if I suddenly have a foreign key constraint that doesn't work that way, I would want to change that, right? I want them all to be consistent and normal throughout. Here's another one, oversized columns. Again, if I don't have much filling up the various columns of my tables, then let's make them right-sized and get them set up in such a way that they are actually consuming the right amount of space, okay? So in executing that, I see that I do have quite a few columns that, the biggest size in those columns is a lot smaller than its max size. So I could be potentially wasting a good deal of space. Fortunately, I don't see anything in here with a character maximum length in the thousands, but some of these, are quite a bit different in size from what they actually need. Got a query in here for you that written by Davide Mauri from Italy, and he's a very solid blogger, writes lots of good content. I encourage you to check this stuff out. And this is a nice little query that tells us whether we have heaps and how many non-clustered indexes we have on the tables in this database. So I would want to put some consideration to anything that has a heap on it, such as the city table. Okay? And also, probably for a lot of these tables, I probably want to see multiple non-clustered indexes. There's another query in here for primary keys. There's one for tables without any foreign keys and foreign keys that don't have any clustered, non-clustered indexes. So I can see all of this information. As I mentioned, if you have tables that have foreign keys, but they don't have that non-clustered index, you want to go back and add those in right away. You'll see an immediate improvement in performance. And I'm going to skip along here. Remember when I mentioned that every time you do insert or update or delete, and SQL Server has to figure out a way to make it work with the clustered indexes? Well, one of the corollaries of that is if you have duplicate indexes, you're making SQL Server do way too much work. It has to do an insert and an update and delete all the pointers in every non-clustered index on there. So if you have duplicate non-clustered indexes, it's a problem. So fortunately in this database, I don't have any. Let's check AdventureWorks just in case. Oh, I've got one in there where I've got one column indexed twice. So I would probably want to delete that, drop that second column. Here's another indication of some significant architectural issues shown to us through perf counters. Okay, so you'll notice I've got one for number of deadlocks per second. This is a pretty serious problem. Usually it indicates your clustered index may be in the wrong column or columns. Forwarded records per second, this is a problem that only happens on heaps. And so if we see a large number of forwarded records per second, in this case I have 0, but if that was a big number, I would know I've got a lot of heaps that are poorly designed. Okay. And then I like to see how many full table scans I have. That could be a number of causes. It could be bad SQL that doesn't access the tables well. But I'd also want to take a look just to see if I have any tables that, again, don't have those clustered indexes. And then I like to look at the ratio of batch requests per second to compilations per second to recompiles per second. And for that particular circumstance, what I want there is to make sure that the ratios are kind of reasonable. So for half of my batch requests per second, I have a compile. And then it looks like for about a fifth or a sixth of the compiles, I have a recompile, which means SQL Server has to start that block of code over before it could completely run through all of the code and finish it. So now 20% recompile isn't a very bad ratio, so I'll just leave that and say, okay, did an okay job on that. But I've talked to people and looked at their databases where they had a compile to recompile ratio of 40-to-1, meaning before a single SQL statement finished, it recompiled 40 times on average. And then finally, this here is another query that is telling me how many full table scans and how many key lookups I have per table. Key lookups are an indication that I could add a column to a non-clustered index or perhaps do an include column, and that would actually improve the situation there. All right, so with that, I apologize for the noise there. Let me go ahead and skip ahead to the end since I don't have enough time to continue. And also, many of the slides here are actually hidden. So there's a lot of slides in there that you could not, you would not see while I was doing the presentation, but that's okay because they were hidden to begin with, and so don't worry about that. There are a couple new ways of addressing your data in the most recent versions of SQL Server that are really worth noting. These are architectural choices. And so the first is column store. Column store is an entirely new way of organizing your data based on columns rather than by the records in there. And it can be enormously faster, 14 times faster. But don't use it on any table that has less than 1 million records. There is another feature called in-memory OLTP, also known as Hackathon, and this can give you even better performance improvements, up to 40 times better. But again, it's a different architecture and don't apply it lightly. The new one that I'm telling everybody to apply all the time, if you have SQL Server 2016 Service Pack 1 or later, is data compression, okay? It uses, my team, Melissa Connors at Sentry One has done a huge amount of testing on this. And one of the things we learned is, except when you're creating the data compression when you're creating it and installing it on the tables. It doesn't have hardly any CPU hit at all. It's about 0.6% on a regular OLTP database, okay? And it decreases the I/O and the memory consumed by the application between 60 to 40%. So it's a massive improvement in I/O, which, if you remember the analogy of filling up our bathtub using the old-timey methods, that's our slowest point, is carrying those data pages from disk to RAM and back. So this means we go a lot faster. So I encourage everyone to use data compression. Now, I will throw out there that we have a full white paper on this, shows all of our test results, gives you lots of great information about that kind of thing. So if you're curious about it, I'd encourage you to take a look and dive in on that. Okay, so we're all out of time. Gosh, folks, I really appreciate you sticking through to the very end with me, and even a little bit after. I know that it's a couple minutes after, and I apologize for that. Don't forget, you can get Plan Explorer free, and also I'm going to extend an offer to you. If you'd like a free long-term trial, basically 1 year of our product completely free. At that point, if you would like that product afterwards, you don't even have to pay the regular license fee. You just pay what we call our maintenance, annual maintenance. It's a fraction of the total cost of the license. I'll give that to you for SQL Sentry. We have a new Essentials product that I'd like to encourage you to take a look at. We have Doc Express, which builds data dictionaries and shows data lineage. We have DBA Express, which does schema compares and 30 or 40 other different things as well. All you need to do to get access to that invitation is to send me an email at kline@sentryone.com, and I'll make sure you get that. So with that, I apologize. I don't have any time to go through the questions here at the end, but in a request to Kevin and Steve, who are running the program today, what do you think, folks? Is this something that send to me afterwards, and I will answer those questions?
Yeah, Kevin, we will actually be sending them to you later on today, hopefully today or tomorrow, so you can answer them at your leisure. I just need, for those of you who actually ask questions, if you can send me or put it into the question box, just your email address, that would be awesome. We'll actually get that over to Kevin here rather soon so he can answer all our questions. And with that, Kevin, I'd like to thank you so much for staying with us and presenting this wonderful topic. It was, as always, very informative. I know I enjoyed it immensely, and probably will be putting some of those tips you put out there actually in use, at least as much as I can anyway. And with that, thank you all very much. Have a great day, and we'll talk at you all next time.
Thank you. Bye-bye.
Bye.